Okay, so we are going to be talking about similarity and transformations. So we've talked about similarity before. This is 8.2b. Similarity we talked about in 8.2a and 8.3. We learned about proportions and we looked at scale factors and how to find missing sides using those proportions and scale factors. So now we're going to talk about how similarity relates to transformations. So a similarity transformation is a dilation or a composition of rigid motions and dilations. Okay, so those are a couple of new vocabulary words: dilation, composition, and rigid motion. Okay, so your rigid motions are things like a rotation, a reflection, or a translation. These are all things that we learned in ninth grade. Okay. So if you are rotating a shape, all you're really doing is turning it. If you are reflecting a shape, you are flipping it. And if you are translating a shape, you are sliding it. So these are rigid motions, and a rigid motion is a motion that preserves, I don't know why I put an extra S on there, preserves your shape. So you are not changing your shape at all, you're just changing where your shape is at. Okay. So you're still having the same shape, you're just moving your shape around. Okay. So a dilation is not a rigid motion. Okay. A dilation is a similarity transformation that changes the size of a figure with respect to a fixed point. Okay. So a dilation is not a rigid motion because your shape is changing. You're changing its size. You're making it bigger or smaller. Okay. So a dilation creates similar figures. Rigid motions create congruent figures. Okay, so remember, similar figures are the same shape but different sizes. Congruent figures are the same shape and the same size. Okay. So those rotations, reflections, translations, we did those last year. If you were in Miss Austin's class, I know, Miss Sutterfield's, I think, Miss Swenson's, or Miss Smith's, my class, we did our quilt projects at the end of the year. So that's what we were doing with those quilt projects. All right, so let's focus now on just dilations. So with a dilation, we are changing the size of a shape with respect to a fixed point. We call this point the center point. Okay. So in this image here, we're using, if we were like standing at this center point, and this was our original image, we want to take this image and expand it to be our new image. But we're doing it with a fixed point so that we're not changing the shape at all. By doing it with this fixed point, all of our angles stay congruent. Okay. So angle A here is going to be congruent to angle A prime. We are just expanding or contracting the shape. the sides. Okay. So we've talked about scale factors a little bit before, but now we're going to be very particular with our scale factors. So when you are talking about a scale factor, we are using the notation P prime over P. Okay. P prime is the point of your new image, and P was the point from your pre-image. Okay, or your original image. When this value or this ratio is bigger than 1, you would call your dilation an enlargement. Kind of like you are zooming in on a picture. When your ratio is less than 1, but not negative, we would call this a reduction. An enlargement is when your shape is growing, and a reduction is when your shape is shrinking. Okay. So let's look at this core concept here. When we're talking about dilations on a graph, okay, if P or point P, which is xy, is the pre-image of a point, then its image after a dilation centered at the origin with scale factor k is the point P prime. Okay, so this picture does a really good job of explaining what that just meant. Okay, if this is our original point here, after we use our scale factor and we do a dilation, we are going to get a point, I can't think of, for our new image. Okay, this was our original or pre-image. We're using a dilation, which really is what we're doing down here. We are multiplying the x and y by some number, and that's going to give us our new image. So we're creating a different image with this shape by multiplying its coordinates by the scale factor. Okay. So this is the dilated image up here. So that's a lot of new information, new vocabulary for some of you guys. Let's do an example to show you what we're talking about here. Okay, so for these two examples, we want to find the scale factor and simplify that ratio. So we've been doing this before. In 8.3 and 8.2a, you guys found the ratio of your sides and simplified those fractions and got a scale factor. This is the exact same thing, only now we're going to use that scale factor to write the dilation. Okay, so this stuff is, at the beginning, is review. The new stuff will be to identify the dilation. So the very first one, those triangles on your grid, okay, we want to find the scale factor. So we want to find this ratio. So all we need to do is find the sides, a matching pair of sides. Okay, so on my smaller triangle or my original triangle, I'm just going to use that top side. Count boxes, that's 2 units long. After the dilation, we get this bigger triangle who has a side of 4 units long. So my scale factor is just going to be that ratio, 4 to 2. I put the 4 on top because that's the image we got after we did the dilation. So we always want to put the one after the dilation on top. So 4 over 2, which we know is 2. So our scale factor is 2, which means this dilation is taking all of your points, which are x comma y's, and they are turning them into the points 2x, 2y. So all we are doing is we're taking everything about this image and we're multiplying it by 2. Okay, we are enlarging this image by 2. Okay. So now let's look at example 2 with the paper clips. And you can see our center point C there. Okay, and that helps us create some shapes that we can find matching sides with. Okay, so for our scale factor, I want to take the after image, which we always use those apostrophes on our letters to tell us which image is the new image and which one was the original image. Okay, so in this example here, this little paperclip, sorry, I forgot the word, the paperclip, the smaller one, is the new image. And the bigger paperclip was the original. And how do I know that? If I look at the letters, this is P, and this is P with an apostrophe. We say P prime. All of those apostrophe ones are the new image. Okay, so I need to create a ratio to find my scale factor. So this scale factor, I take the new image, which they give me a length from the top of this paperclip to the point C. They say that length is 18. But from my original image to point C, that distance was 30. So my scale factor takes 18 to 30. And now we just want to simplify this. So this is 3/5. We could also write that as a decimal, 0.6. So again, that's stuff we've already been doing, finding the ratio of our sides. Now what we want to do is identify the dilation. So how are we getting from that bigger paperclip to that smaller paperclip? Well, we're taking every point x comma y, and we are multiplying it by that 0.6. So 0.6x, 0.6y. Okay, so this is not an enlargement, this was a reduction. It didn't ask us to find that, but because that scale factor is less than 1, we have a reduction. Because this original scale factor, for example, 1 was bigger than 1, we had an enlargement. Okay. Whoops, sorry. So now let's talk about them on the grid. We're going to draw our own original image and then perform a dilation and figure out what happens when we do that. Okay, so we are going to first graph triangle ACD with the coordinates 2, 1, 4, 1, and 4, -1, and then also graph its image after a dilation with a scale factor 2. Okay, I'm going to change these points a little bit because when we do our dilation, we're going to end up off our graph a little bit. So I'm going to change all of the x values to be negative. Okay, so instead of 2, 4, and 4, it's -2, -4, -4. Okay. So let's graph that original triangle, ACD. So A is -2, 1. B is -4, 1. And C is -4, -1. Oops. So here is my original image triangle. Here's A, here is B, and here is C. Okay, so we want to take this triangle and we want to perform a dilation with a scale factor of 2. That scale factor is bigger than 1, so I know that this is going to be an enlargement. I'm taking my triangle and I'm making it bigger. Okay. So I'm going to fill in these 3 points here, A prime, B prime, C prime, to figure out where I'm going to graph this new bigger triangle. Okay, so remember when we're doing a dilation, we're taking that scale factor and we're multiplying the point by that number. So if my original point A was 2, 1, then my new image, A prime, is going to be 2 times 2, and 2 times 1, which is 4, 2. My new point B is going to be, oh, and you guys, I changed the points a little bit. I'm so sorry. These are supposed to be negatives because I moved them negative so I could fit on the graph. So my new point A prime is going to be negative 2 times 2 and 1 times 2, which is negative 4, 2. My point B is going to be negative 4 times 2, 1 times 2, which is negative 8, 2. And then negative 4, negative 1 turns into negative 4 times 2, negative 1 times 2, which is negative 8, negative 2. I'm off the graph here as well, but at least I'm going off a direction where I have room. Okay. So we know our triangle is getting bigger. I'm going to graph these 3 points that I just found. I'm going to use a different color here. Let's do this one. Make it a little bit bolder. Okay, so my first point is negative 4. 1, 2, 3, 4, 2. And then negative 8, which our graph only goes to negative 5. So I'm going to be off the graph again. Negative 8, 2. And then negative 8, negative 2. Okay. So this point here is A prime, B prime, and C prime. So our triangle did get bigger, and it moved over a little bit because it got bigger. Because we were changing all of our points, it affected not only how big it was, but where it was on our graph. Okay, so that's why this is not a rigid motion. We're changing where it is, but we're changing also what the shape looks like because we're making it bigger. So this is a dilation, and we are enlarging this. Okay. Let's do it one more time, or at least use the one that they've given us to find the scale factor. Okay, so we want to describe this similarity statement relating the smaller image to the larger image. And we're going to include the scale factor and the dilation in our description. Okay. So the way this is worded, it says we want to relate the small image to the large image. That means that the larger image was my newer image. Okay, the small image was the original, and it's going to the new image. Okay, so when we create our scale factor, we want to take P prime over P, right? So that means that I'm going to be looking at my larger image over my smaller image. Okay, so we could use a bunch of sides. They have 3 different sides we could create a ratio with, but honestly, I'm just going to pick, actually, let's do a different one. I'm just going to pick this side here and this side here. That's a matching set. So remember, on top of my fraction, I want to put the bigger image. So the bigger side is 1, 2, 3, 4 units, and the smaller side is 2 units. So 4 to 2, which is 2. So my scale factor is 2. So my dilation, and this is kind of what we did at the top here, identify the dilation. My dilation takes every point xy and it turns it into the point 2x, 2y. So is this an enlargement or a reduction? Well, we're taking a smaller image and we're turning it into a bigger image. This is an enlargement. And that's it. So dilations, we're taking those scale factors that we've already learned, and we're using them to write dilations, which is a similarity transformation. It creates similar figures, not congruent figures, okay, because one is going to be bigger than the other. So if you have questions, let your teacher know, and we will be moving on to 8.4, 8.5.